Assalamu alaikum dear students. Today we are going to discuss binary operation. Since we know that in mathematics we have four fundamental operations, or we have four basic operations, which are subtraction, addition, multiplication and division. But when we consider these four fundamental operations on a different sets, the properties of these operations varies. Like if we consider n the set of natural numbers, and if we consider the subtraction over n, that is subtraction on set of natural numbers, then you know that a minus b is not equals to b minus a, where a is natural, b is natural. Like 2 minus 5 is minus 3, and 5 minus 3 is 3. So 5 minus 2 is 3. So this means that this subtraction is not commutative over naturals. But if we consider this also, if we consider this subtraction over n, then a minus b does not belongs to n in general. Like if we consider 5 and 2, 5 minus 2 is 3, that is natural, which implies that this operation connects two elements, that is 5 and 2 in n, while as 2 minus 5 equals to minus 3 does not belongs to n. So this means that this under this subtraction, a minus b does not belongs to n in general. While as if we consider the same operation over or, that is set of reals, then a minus b is always or, is always a real number, that is a minus b belongs to or always, although a minus b not equals to b minus a. So this means that from this we conclude that the operations, any operation, this addition, subtraction, division and multiplication, it varies, its properties varies from different set. Now if we consider addition over n, then a plus b always belongs to n, that is sum of two naturals is again a natural. So we can say that this plus or this subtraction of this addition operation obeys closure law, obeys closure law. That is, when we combine any two elements of n under this operation, that is under subtraction, this addition operation, we get a new number which is again in n. So closure actually means if it closure law, or we say that the given operation satisfies the closure law if we operate, if we connect two elements of a given set through this operation, the resultant is again in the given set. While as if we consider the subtraction, like here subtraction, it does not obey the closure law in a set of natural numbers, because a minus b is not in general this natural number. So addition combines two elements to a new element which is again in n, while as the subtraction does not combine two elements of n to a new element which is again in n in general. So this addition here is simply called as the binary operation. Binary means two, so binary operation is simply that operation which combines two elements of a set or of a given set to a new element which is again in set. So how can we define this this binary operation? If we have a non-empty set A, and star is the binary operation, star is the binary operation if star is the function from a cross a to a, that is it combines two elements of a to a new element which is again in a. This for all a b belongs to a. Here a star b belongs to a. Like if we consider this star is here defined as star of a b equals to a star b. So we can say simply star is the binary operation on a given set if it connects two elements of a to a new element or to an element in a. Like if we consider plus from n cross n to n defined by plus of a b equals to a plus b, you know that a plus b is always natural for all a b belongs to a n, which implies that by definition star is the binary operation on n. Again, if we consider this subtraction, that is minus from n cross n to n defined by minus of a b equals to a minus b, this minus is here not, or this subtraction is here not binary operation, because 2 belongs to n, 5 belongs to n. Minus 2 5 by the definition is defined by 2 minus 5, which is minus 3. Minus 3 is not natural, so this means that this minus is not binary operation. Now what are the properties of binary operation? First one is the commutative. Now star, if star is the binary operation on set A, then star is called as the commutative if A star B equals to B star A, like 5 plus 2 equals to 2 plus 5. So this means that star is, this plus is here, the commutative is commutative, or satisfies the commutative property. While as if we consider binary operation subtraction over OR, it is not commutative. Now associative is star is associative if A star B star C equals to A star B star C for all A B C belongs to A. Now the third property is the existence of identity. An element E belongs to A, where A is the given set, a star is the binary operation, then E is called identity under this operation star, or is called identity of this binary operation star if A star E equals to A for all A belongs to A. Like if we consider Z set of natural numbers and we define binary operation, or plus is here the binary operation, 0 belongs to A plus 0 equals to A for all A belongs to A, for all A belongs to Z. So this means that 0 is the additive identity, that is star identity. Also if we consider this natural numbers and this plus as the binary operation and is the binary operation, A plus 0 equals to A for all A belongs to N, for all A belongs to, but 0 does not belongs to N, which implies that under addition identity does not exist for the set of natural numbers, although it exists for set of integers, because this 0 does not belongs to N. Now the fourth property is that existence of inverse. If we consider A element of A, star is the binary operation on A, then if there exists an element B which is in A such that A star B equals to E, where E is this identity under this operation star, then B is called as inverse of A. Like if we consider A belongs to an integer, star is binary operation, then A plus minus A equals to 0, because if A belongs to Z, minus A also belongs to Z, then their sum is 0. 0 is additive identity, which implies that minus A is inverse or additive inverse of A. Similarly under multiplication you can define the additive, you can define the multiplicative identity and multiplicative inverse. Like if we consider 1 over 1 belongs to OR, then A into 1 equals to A for all A belongs to OR. So 1 is multiplicative identity, but multiplicative inverse, A into 1 by A. If A is non-zero real, then A into 1 by A is 1. So this means that the multiplicative inverse of A is 1 by A provided A not equals to 0. So in this way you can use, or you can find any the multiplicative inverse or this multiplicative identity or binary identity or inverse of any operation on any set. So this was all about this binary operations. So from tomorrow onwards we will discuss another unit, that is trigonometric functions. So thank you.